Um, okay, so we ran into last month, a UR encoded object in the wild that kind of surprised me. So I wanted to invite them to come here and share a little bit about their particular solution, and they also had some suggestions or some questions around fountain coding and such. Do you have a presentation, or you want to share your
Yeah,
screen?
yeah, I could share my screen. I think people can go into seedhammer.com and just get. But I'll quickly just run down what it is. So Seedhammer is basically a print to steal, a backup your Bitcoin wallet and seeds to steal, and we want to position ourselves as the printer, steel printer, if you want, for anything, for any backup needs you have. The advantages, of course, there are many steel solutions already. There are the manual ones, basically. There are washers, there are metal plates that you can hammer on, there are engraving toolkits and so on. So the difference between all those and ours is that we sell a machine. So it's an automatic backup generator or printer. And by having a machine and, of course, the blank plates, you can print much more on the plates. So it's practical, but difficult to do your seed words manually. But with our machine, you can do not only the seed words, you can do a seed phrase, for example, a BIP 39 seed phrase. You can also do the corresponding QR code, which is cool if you have a stateless signing device. And even more importantly, you can actually back up the complete all of the information that is required to restore your wallets, in particular multi-signature wallets. And the way we do that, I can link to a very short video that demonstrates what is possible. For example, if you have a 2 out of 3 setup, you will get or have engraved with the Seedhammer machine 3 plates. And each plate will have a seed phrase and the CQR that matches that seed phrase. And on the back side, it'll have a fountain encoded, I think you call them parts. So it's a QR QR code containing the complete the complete output descriptor, but it's split up into parts. So only so for example, if you have a 2 out of 3 setup, you will need 2 plates, 2 shares. And we use fountain encoded, the fountain encoding of UR data encoding to make sure that we don't we only have to store the required amount of data. So instead of encoding a complete descriptor on each plate, which is quite a lot of data, we can engrave only half of the descriptor on each plate, or the amount of data corresponding to half of the descriptor. And because of fountain encoding, any 2 plates will recover the wallet. So just to, in the example of a 2 of 3, if you are familiar with the fountain encoding, it's more or less you split up your data, in this case an output descriptor, in parts, and we have 2 parts, and you can then encode either a part, or you can encode an arbitrary XORed combination of parts. So for a 2 out of 3, the first plate will contain the first part of the 2. The second plate will contain the second part of the 2, and the third plate will contain the XOR between the 2 parts. And if you work it out in the head or something, you can convince yourself that either 2 of those 3 UR codes will recover the complete wallet. Of course, the 2 first plates is trivial. That's just the 2 parts. And any plate with the third plate will also recover, because you can use the plate with just 1 part to sort of factor out or XOR out that part from the third plate. And we do something similar for 3 out of 5, where it seems to be necessary to use 6 parts. So you will end up with 2 QR codes on the backside of each share. And the XOR scheme is more complicated, but the result is the same. Any 3 plates of a 3 or 5 setup when you scan all the 6 QR codes on the backside, you get a full recovery of the descriptor. And that's sort of the unique thing about Seedhammer. You can do many other things with it. You can do gift cards, so you only need a single signature. You can print just the words. You can print one of one with the descriptor on the backside if you want to make it easy to scan to check the balance, or just to see the addresses or whatever. So of course there are many secondary advantages with Seedhammer, but right now it's the multi-signature complete backup thing that is the unique thing for us.
Yeah. So what's fascinating to me when I look carefully at the some photos that were shared by them was, of course, it had the UR at the beginning of an engraving that was also in the QR code, so you could compare the engraved text with the QR code that was on the same metal thing. And I looked at it and went, oh, that's kind of intriguing, because if we go back to the ledger problem, ledger forced you to use 2 parties that limits you to a very particular type of scenario. And we've long, I know with one of our multi-sig scenarios that Shannon designed for I think it's Sparrow, Seed tool, and Foundation Devices, we are putting a seed into storage offline to, and then the other 2 are basically cloud accessible services that we want to be able to do offline. But I think this idea of being able to leverage some of the offline capabilities of QRs is very interesting. And especially when we start talking about CSR and some of the new features of Rust. So one of the latest features of Rust is that, the Rust library is that we ended up adding a new major category to the envelope specification, which is also compressed envelopes. So we actually have the ability to compress envelopes, which will help make things fit onto multiple, metal backups if people want to do that. And but I also think that there's some other, understanding more about the limitations of how much you can fit onto one of your metal backups. There may be some other very interesting things we can do. I mean, I've been saying for a while, I've been very uncomfortable with the fact that descriptors are descriptors are actually not that large. We end up by entangling, encoding, and then encoding it again, and then putting headers on it and whatever. We're making these very complex structures that have lots of layers to be able to decode it, to be able to use in our multi-sig usages. But in fact, if you have a binary format for that, it actually is fairly compact. So that's another opportunity, is for us to basically go, hey, here is, BIP 900 or whatever, I have no idea where the BIP numbers are up to now. But here is a binary version of a descriptor that is, very compact, and recommend to the Gordian community use this because it's a lot smaller and will allow for unusual scenarios, including a complete offline scenario. But I think there are other opportunities as well. So I wanted to make sure that the Gordian community was aware of your tool and, as an option, and work with you on extending it and standardizing it.
Yeah, the one thing I didn't mention that may not be apparent is that by using the UR types and the fountain encoding that already exists for other purposes, which is transferring a descriptor through animated QR codes from in an air gap way from a controller wallet to, say, a signer or hardware wallet, we use the same standard. So our plates, that is from the second video I linked to. So our plates can actually be scanned by Sparrow, and very recently can be scanned by Nunchuck. Anything that supports the UR standard, in particular the binary version, BCR, is it 010 or something? The output, crypto output, I think the name of it is. And not many wallets do that, or some do, and I'm sure they will eventually end up doing that. But the cool thing is that this is just abusing, so to speak, a standard which was meant for animated QR codes, but we can actually brute force the founding and coding to give us the XOR part combination that we want. So I think that's one of the very, very interesting and cool things about Seedhammer. Of course, I'm from Seedhammer, so I have to say that. But I think it's cool that you're not required to use, you're required to use our software to do the engraving, but you can and should use some other software to both verify when you first set it up, but also when you 10 years down the line wants to recover and don't have anything, or your heirs, your daughters, your sons, your family wants to recover this. It's a standard, hopefully also in 10 years, and there's nothing Seedhammer specific about anything we engrave on the plates.
Right.
Yeah, and I thank you for the standard, because, as you said, you may be able to do it even more, encode an output descriptor even more compactly, but I think it's already pretty compact, the BCR 0010, the crypto output. So it could be made a little bit smaller, but not that much, is my
Well, it can be about half. I mean, well, 6, whatever, but that's beside the point. I think the point is you have a little bit more room. There may be some other useful things that we can do to either you know, increase increase the reliability or offer some other capability. So for instance, you know, you could have a I'm not sure if I precisely recommend this, but just showing that it is possible. You know, you could have a BIP39 seed that is encoded that requires you know, a 2 of 3 to restore. But if you happen to have a 3 of 5, you know, one more than what you had before, that you could also restore a BIP38 secret or some other secret. So there's some interesting you know, options again for offline keys that, you know, might be possible with some of these scenarios. And then obviously, you know, we're not just working with the cryptocurrency community, we're also working with the digital identity community, and they have some unusual needs of things that, you know, they would like to be able to do. And some of that is more dealing with the social key recovery side of things. And then when you say, go ahead.
When you say you can compress an output descriptor to about half, do you mean by using the private keys instead of the public keys?
No, we're still using the so right now descriptors are I mean, Wolf actually has more details on it. But
well, yeah. I mean, descriptors as they're defined are text, and a binary version of that basically is wasting bits in each character can be, you know, by virtue of that, a lot smaller, depending on, you know, so that, you know, that might save you like 20-30% right there in terms of just having a binary format for descriptors as opposed to a text format.
But isn't your format already binary?
Not for descriptors.
Let's see. Well, actually, I'm trying to remember at the moment. It's been a while since I've looked at that code. But yeah, I think we do have a binary version. The other way of compressing is that Gordian envelope itself. The standard now defines a way of creating an encrypted version of a compressed version of an envelope, in our reference implementations using the deflate algorithm. So depending on how you know, how you tune that algorithm and how the size of your input data, you might get another 20, 30, 40% savings, depending on the size of the data you're putting into it. Obviously, the less data you put into it, the more likely it will be that won't be many redundancies that the deflate algorithm can remove.
But for XPubs, you can't really compress them because they're more or less random, right?
Well, yeah, I mean, random data is the hardest to compress. But you know, you could probably, you know, save some space. I haven't done experiments
Yeah,
directly.
that'll be trivial
descriptors.
and somewhat accidental. In fact, if it compresses too much, that's usually a sign of something bad in your.
Well, it's lossless, so it can't actually take anybody. The thing is, the worst case, you know, your message is small enough and random enough that the overhead of the data it needs to add to it actually, you know, creates a larger compressed message by some number of bytes than the original message.
So I mean, it's not so much the keys that'll compress, it's all the other data. When we start talking about time locks, we start talking about all the different things that can be expressed in a descriptor. Almost all of those are text values.
Yeah, absolutely.
And I think there's a better way of doing it if there's a will, if there's a need. So, but I think that's one of the main points is, you know, we need to discover where the pain points are for, say, proxy. So proxy is one of you know, he's the one who implemented the SSKR for Java card. Well, they just got acquired by the Aura ring. If you're familiar with this is a ring sensor that biometric. When you put it on, it recognizes, well, the Aura doesn't, but the next version will recognize your fingerprint when you put it on, and then you basically, it has a liveness thing that basically says you have not taken it off. So it's a lot more like an Apple Watch than it is the current Hour ring. And but there's some particular problems in the sense that the Hour ring doesn't have a trusted display. And it doesn't really have trusted input. I mean, you can tap the ring against a hard surface and then have the accelerometers in the ring basically know, oh yeah, my owner, you know, has the ring, and you know, maybe 3 taps is a consent, you know, to say yes, go ahead and sign this. But it's not, you know, it's just not a reliable way of doing a lot of different types of operations. So they have a very particular problem where there are really 3 parties involved. There's the transaction coordinator, the equivalent of Sparrow, but then there is a trusted device, which is, you know, right now an iPhone app that has a trusted relationship with the Hour ring. But you don't want you to have to use that trusted iOS device. So we've been working with them on how, you know, a third party could write an app that would take over with the permission of the user to the official, say, Aura app for iPhone, and be able to have it give permission for a new app which was designed by another party to basically give you access to the details on the Hour phone. So there's a lot of different weird things in their wallet that they have to do, and yet we still need to be able to archive, you know, keys, multi-sig type of data, etc. That they would love to be able to have the option for an offline, one of those to maybe be offline, and you give them that potential. So, but again, just different wallets, different scenarios.
We can, of course, it's another cool thing about the way we do it, because of upper descriptors and so on. You can actually do one plate at a time, one share at a time, if you have the whole descriptor. So say we are 2 or 3 people that want to do a shared multisig. You can have either a Seedhammer each, or you can have a Seedhammer that you sort of go take turns with, and as long as you somehow, and I think you have strategies or protocols for agreeing on a multisig output descriptor. Once you have your seed, your part of the multi-signature setup and the full multi-signature descriptor, you can use those 2 things to engrave just one plate, just one share, and you will still have. And you don't need to have everyone in the same room and so on. So, yeah. There's
some other things going on. So obviously we want to move ultimately off of the limitations of Shamir and move to true threshold signatures, whether or not it's the fairly well-reviewed Frost function or MUSIG2, or some of the newer ECDH threshold signatures that don't require Schnorr that are emerging. All of those I think have some interesting scenarios where, you know, an emergency member of the quorum can be offline. But those functions are complicated in the sense that it's, you know, it's not just as simple as having this static data. It, for instance, might need to know what the public key is to communicate with one of the other quorum members, like a signal address or a Tor address or something of that nature. So that's yet another, when we sort of moving into these, multiprocessor versions of these technologies, being able to have a very strong secure backup for those is interesting. There are other interesting scenarios. So one of the things, let's say you have a 2 of 3 of 2 of 3s, you know, my favorite little 4 of 9 variant, where you have different levels of control. You can do that in a multi-sig scenario as well. But then let's say that, you know, over time, you know, 3 of those partners in different things have become corrupted, lost. You can no longer do a verifiable secret operation to determine that they're out there. And basically, if you lose one more, you lose your quorum. So you want to be able, before that happens, to create a brand new quorum. And once again, that's another place where being able to have an emergency share to help reform a new quorum may require some additional data that that is along the lines of a descriptor. It's not precisely the key material, but it's sensitive, and you need to store it as well. So store it in a sensitive fashion. I don't know. I liked your tool. You also were, we did an experiment a couple years ago called LeafyKit, which was basically a very cheap ARM processor that has no local memory, so that as soon as you turn it off, it loses all the keys that are in it. You are doing some similar types of things. You're trying to make the hardware not store things. And some of the work that's being done on the Silicon Salon, some of the work that we did for LeafyKit or whatever, are in that same vein. I mean, I'm trying to talk a couple of these silicon companies, say, heck with your high-end silicon processor. I just want one that can do SecP and has no memory, no networking, just the minimal. But be able to do those operations in a secure fashion without side channels and all of that. So, any questions for the Seedhammer folks?
I have some questions.